So welcome everyone to Guided Study Group Week 3 of Math 141. So it's the last week before the midterm, and you're going to see at the end of these sessions, I'll have like 20-something practice problems for to kind of like help you review for the exam first. Next week, I'll also have an exam review, but it's just going to go over some of the practice problems in the practice exam. So I kind of like going to go through your grades, like how you guys did on that practice test, and I'll pick out some of the hard problems. So I would highly recommend for next week, please do the practice exam. I know it counts as some credit, but don't wait until my sessions to do it to get the answer. But try to do it beforehand, and if you have any problems, I'll know it based on your grading, and I'll just pick out the hard questions to solve it. Good. Alright, so we're gonna get started. So let me get to the, okay. So okay, on Thursday. That is hard. Let me think. Do you have access to my I think the practice, so if you have any problems with the practice exam, like say if you're doing it and you finish it and then you see there's something that you got wrong, you can send emails to me ahead of time and I'll answer it. How's that? Yeah, I think I think it's already on Canvas. Okay. All right, so let's get started. So it's 7.3 tricks up. So basically now today we're gonna go through like the last 3 sections before of integration. So 7.3 is another technique to find integration where we call tricks up. 7.4 is partial fractions, and 7.5 is just when you put all of the techniques together and we have strategies of integration. Now, tricks up is a form to find integration, and the way that you're going to use it is that basically, usually you're going to substitute some function as u equal to fx, but now what you're going to substitute is x is another function of some other variable. And to do that, whenever you see one of these form, say square root of a squared minus x squared, square root of a squared plus x squared, or square root of x squared minus a squared, then these are the substitution that you're going to use. And always remember to do this kind of like change of variable, because when you go from x to theta, then the boundaries also changes. So you say if this is a, b, here you're gonna have c or d. So make sure that you do that and don't forget that part. So the step to do is you put it in the right form. So even though you have just like a small suspect of that is gonna have some form of something square minus or plus x squared, try to put it in the form, and sometimes it usually works in this kind of form. And then you're gonna use up and tricks up. So use up is where, because of the fact that sometimes you have, say, like in this example, or like you have 4 minus x plus 1 square and with a square root. Then if you put u as x plus 1, then you have 4 minus u squared. Now you can do u equal a is 2, so you have 2 sine theta. So it's kind of like a double step, and this should be the form that you should expect like to be tested in the exam, because obviously in the exam it shouldn't be that boring when you just have one technique. And it usually is a combination of more than one thing. So if you were asked to take integration in the exam, it's usually going to be like first you do use up, some else, after that you're going to do something else, or you're going to do partial fractions, and then you have tricks up or something like that. So it's usually a combination of 2 techniques. Then the final step is that after you take u sub and do trig sub, you solve the integration and you have everything in theta. Now use the right triangle relationship that we learned last week to put it back into x. So multiple steps, but once you get it, it's gonna be really quickly. So for first example, let's start it with this. So if you want to join me to do it, feel free to do that, or you can just mute me and let's maybe like when you watch this video again and see what is the answer. So for this one, in the numerator, I couldn't really see anything about x squared or not, but in the denominator, you have the square root and you have also something with x squared. So look at this, 3 minus 2x minus x squared. I kind of like want to put it in the something a squared minus x squared form, because or like a squared minus something of x squared. So that I can use u sub, and it's exactly is the case here. So we have let me do this. So we have 3 minus 2x minus x squared. I want to complete the square over here, so you're gonna have minus x squared plus 2x plus 1. So this is complete the square. When you take the negative out, everything inside is positive. So if you minus 1, you have to add 1 outside. So 3 add 1 is going to be 4. Therefore, what we have is 4 minus x plus 1 squared. So this integration of us now become 3x divided by 4 minus x plus 1 squared dx. Now we have, as I said, it's kind of like you can clearly see the fact that here you can do x plus 1 equal, you can do trig sub here, but you have to resolve the x plus 1. So what I'm going to do is I put u as x plus 1, du is dx. Then this thing is now equal 3 u minus 1, 4 minus u squared du. Now here let's do trig sub. You have u equal 2 sine theta. Why 2 here? Because a squared minus u squared. So a squared is 4, so a is going to be 2. So you have du is 2 cosine d theta. Now this part is going to equal 3. U is 2 sine theta minus 1 divided by square root of 4 minus 4 sine square theta multiply 2 cosine theta d theta. Again, stop me anytime if you don't understand what the hell I'm doing, because I usually go fast, but if it's too much for people, let me know. Then you have 3 2 sine theta minus 1 divide, this is 2 cosine theta multiply 2 cosine theta d theta. So what we end up having here is only 3 2 sine theta minus 1 d theta. And so now it's very easy to just take this integral. So it's 6 sine theta minus 3 d theta. Or we actually have, it's going to be negative 6 cosine theta minus 3 theta plus c. Remember, this is an indefinite integral, so you need the c behind it. But things are easy now, so you get everything in theta and you solve the integration. The last step is to use right triangle formula to put it back in. So you have, this is theta. So you have, let's see what we put here. So you have u equal to sine theta, or you have sine theta equal u over 2. So sine is opposite divided by hypotenuse, so u over 2. So in this case, the last sine is going to be square root of 4 minus u squared. Now, therefore, we're going to put it back into negative 6. So cosine of that is going to be square root of 4 minus u squared divided by 2. Negative 3 inverse sine of u over 2 plus c. Now you put everything back into u. The next step is put everything back into x as they give us. And so it's -3 square root of 3 minus 2x minus x squared. Because we have 4 minus u squared is this part, that the first thing that we do. -3 inverse sine of, oh shoot, x plus 1 over 2 plus c. So this is my final answer for this exercise. The key thing to remember here is that first of all, you have to be able to put it into the form that first. Then you know the fact that you have to use u sub to make lives easier and just easier to keep track. Then it's trig sub. And then finally is the right triangle formula. Now, one of the way that kind of like I would show you, like if you look at here and when you start to use the right triangle formula, if you want to make sure that everything you've been doing is correct, one of the way to check it is that one of the side of this triangle is going to have the form similar to one of the expression that you got earlier, that you were given. So say here, if you have a fraction of 3x divided by square root of 3 minus 2x minus x squared, when you want to check it back, when you have this right triangle, see this sign here, square root of 4 minus u squared, basically is square root of 3 minus 2x minus x squared, exactly as the denominator of the given fraction. So that's one of the ways you check that you've done a correct thing. If you make any mistake in between and say maybe like missing a variable or a term, then in this case, you can clearly see the fact that, okay, you did something wrong when it comes to the right triangle formula to check it. Before I go to the next example, is there any questions so far? No, it can be a lot of stuff to digest. Okay, so yeah, the next problem I'll go slower, but is there any questions with this one? I mean, I would explain it here. If you have any troubles with these questions. Oh yeah, Kevin, in the case, can you put your PSU email in the chat room? So, again, can I ask which part in this thing, is there anything in this questions that you don't understand? Then I'll explain it. Okay, so if not, I will go to the next question. The next one is kind of like easier, so it shouldn't be too bad. So CWB 19. Yeah, please feel free to like stop me anytime when I explain it. Be like, wait, I don't understand this thing, and I'll answer it. So this one, yeah, I'll go slower. So here we have square root of x squared minus 25 divided by x cubed dx. So in that table that we have, that is going to be the form of substitution of x equal a secant theta. So here we're going to do that substitution. So a here, a squared is 25. So a is going to be 5. So it's 5 secant theta. Now, what you need to know here is that what is the derivative of secant? And it's 5 secant square, secant, not square, tangent d theta. And then here is, again, is the indefinite integral, so you don't need to do the change of variable. So now this one is going to become square root of 25 secant square minus 25 divided by 125 secant cube theta secant tangent. Remember, there's another 5 here. I usually forgot it. It actually killed me in one of the quiz, but yeah, should always remember. Just copied out the correct here, the correct form. So we have 25 secant square minus 25. If you take 25 out and you have secant square minus 1 divided by 125, or just 25. I'm going to cancel out with this 5 here. So secant, the secant cancel out with this secant, so it's secant square tangent d theta. Now, Here we have secant square theta equal to 1 plus tangent square theta. So this part is going to equal square root of 25 is 5. Square root of secant square minus 1 is square root of tangent, which is going to give us tangent divided by secant square tangent. Now, what we have here is just 5 tangent square over secant square d theta. So before I go any further, any questions over here with what I've done so far? Even if you don't have any questions, just type in the chat room so that I know, like, what am I doing good or am I going too fast? It's 25 secant square. Oh yeah, you're talking about the denominator? Yeah, it's 25 secant square because I cancel out with the secant here. Do you see what I'm saying? Here you have secant cube and this is secant. So I cancel one out. So it's kind of like 2-step combined one. Is it clear? Okay, yeah, sorry. So I'm just gonna rewrite it. Here, 25 secant square theta. Better? Okay. So yeah, I'll rewrite these things, make it easier to read. Oh, the step before that. Okay. The step before that is, okay, so you have 5 secant theta. So I'm gonna cross this one out and cross this 5 out so that you know the fact that we cancel it out. Okay. Okay. First, the denominator. So it's this thing. 125 secant cube theta. Is it better now? Yeah. Okay, so we're here. And so now we have tangent and divided by secant. Obviously, when I look at this, I will have no clue like where to go. But one of the way that we can resolve this is we're gonna use oops. One of the way we're gonna use this is that we can put it back into the form of, so say we have 5. So there are 2 choices here that you can choose. First is that you put it back into sine and cosine. So tangent is sine divided by cosine, and secant is 1 over cosine. That is one of the key that I usually deal with these problems, because when it comes to trig, and you look at an expression and you have no clue where you're going, one of the way that I always go back is that I'll look at the definition of tangent and secant, and I try to put it in like a different form. It's just another technique to manipulate your expression and make it like easier for you to apply another integration way in it. So here you can choose to do that. Put tangent into sine divided by cosine, secant into 1 over cosine, and you're gonna do the algebra, and eventually you're gonna get to the same destination if you do the second way. So the second way is that you're gonna use this expression again and put it back into that form. So give me a second. I'll pull out my notes to make sure that I choose the correct one. It's like a lot of things to remember. Here's the trig integral. When we have okay, cool. So obviously you couldn't find it, so we're gonna just figure out here. So you have secant square. Let's write better. Secant square minus 1 divided by secant square theta d theta. Now what we have is 5 because 5 secant square. And let's do another step just to make things clear to people. Minus 5 divided by secant square d theta. Now, we're just going to have 5 secant square divided by secant square is 5 minus 5 secant square. Remember, secant is 1 over cosine. So negative 5 over secant square is just basically negative 5 cosine square d theta. Now, you can take make life easier here again. When you take this 5 out, inside you have 1 minus cosine square. So this is the second expression when I use sine square theta plus cosine square theta equal 1. These are like the core principles of kind of like trigonometry. So always keep it in your mind because there's always going to be a way that you're going to use it. So here we have what I end up having is just 5 sine square d theta. So before I go further to use the double angle formula to solve it, is there any troubles with where I'm going? Like when I go from this to here. Any questions so far? I want to make sure that you guys understand every single step so that you can be able to do all of these on your own when you actually try my practice problems, because they're usually at this level, and I think it's a good preparation for exam. It's slightly harder than the actual exam, but it's always better to know more. When did the 25 secant square change to secant square? I think that's a good idea. I don't know where I missed that. Yeah, I'll put it back. That's a good one. You corrected me. So we have 25. Oh, shoot. 25. We have 5 over 25. And this is 25. So instead of 5 here, what's wrong with this technology? 1 over 5. Oh, good. So basically, you substitute x with the trig function and simplify it as much as possible. Then you substitute back in the x value using the right triangle. Exactly. Yeah. It looks, you get the core of the thing. Yeah, so basically, not just like simplify it as much as possible. You try to like solve the integration. So first, you're gonna substitute x with the trig sub. Second, simplify it. Third, take the integral. When you have the final integral of just in, like it's gonna be in the form of theta, use the right triangle formula to put it back into x. Yeah, that's basically what I said here in the step. So use u sub and trig sub, solve it, and then use right triangle formula to get it back into x. All good? Okay. So now we have secant square. Oh, so by definition, secant square. Oh, shoot. Okay. By definition, secant is 1 over cosine. So when you have negative 5 over 25, so there's another step I do here. Let me write in another color. So this one is basically, what's wrong with this technology? It's always get like that when it gets hot. So it's 1 over 5 minus 5 over 25 secant square d theta. So here you have, so 1 over 5 over 25 is just 1 over 5. 1 over secant square, so you have 1 over secant is going to be cosine based on this, right? So I'll just basically do the step here that you instead of secant, what is this technology doing? Okay, you have secant equal 1 over cosine. So 1 over secant is just going to be cosine. It's not apples and Windows. It's actually I'm using Zoom on Windows, so Windows is not I've been only using Windows. I have no idea how to use Mac, but whenever this tablet get hot, it's just gonna usually jump on its own a little bit. It's get a little bit crazy with technology, but yeah. So Natasha, is it clear how I get from secant to cosine? It's good you guys asking these questions because in the exam you guys gonna understand all the steps. I'm actually really happy right now. So we're all good, right? Or are you still struggling with the secant square to cosine? Okay. I'll take it as you understand it because no one actually explained me. So anyway, so we have it here. How does that work with secant in the top and bottom? What do you mean? Like, yeah, I'm confused a little bit now. How does that work with secant in? So the secant here, you have, yeah, you have 5 secant square. So, okay, there's another step I'll do here. So before I go further, I will split it into okay, you're gonna have it here. So it's gonna equal 5 secant. So basically I split this fraction. So you have that minus 5 over 25 secants. D theta. So when I split this, then you can simplify this at 5 secant squared divided by 25 secant squared. It's just going to be 1 over 5. And here you're going to, oh, shoot. And then here you're going to have this. You're going to have 5 over 25 is 1 over 5 secant squared d theta. So when you have that, then it's going to be 1 over 5, we keep it, but then 1 over 5 secant square, I put it back into 1 over 5 cosine theta d theta based on this green expression. So does it feel better now? Yeah, I mean I should have just written them all down, but I just don't want to bore you guys out. But okay, so we're all good. So now we end up with 1 over 5 secant square based on secant square plus, no, not secant, 1 over 5 sine square, because sine square plus cosine square is 1. Now just use the double angle formula to solve it, and then we're going to use the right triangle relationship to put it back into x. So that's basically is a step, and we're going to, so just make sure that you guys don't get lost with me. So we have sine square is going to be 1/2 of 1 minus cosine 2 theta d theta. Then we have is 1 over 10, 1 plus cosine 2 theta d theta. And this one, if you solve it, what we have is going to be 110 theta minus 1 over 10, 1 over 20 actually, sine 2 theta plus c. Now, a lot, it is 1 over 20, just make it clearer. A lot of you might be asking me, okay, how do we do with sine 2 theta? Well, you don't know, if you do have a right triangle formula, right? You only have, let's see what we put here. X over 5 is secant. Secant is hypotenuse divided by adjacent, so x over 5. And so this one is square root of x squared minus 25. And it's, okay, it's kind of like give us a confirmation that what we've been doing is correct, because it gives us square root of x squared minus 25, which is exactly the numerator as given. So it's one of the way we check it, as I say. But here, our concern here is that how do we express these in the form of sine theta, sine 2 theta? Of course, a very easy thing is that sine 2 theta is definitely not 2 sine theta. It's not that simple. Here we're gonna use the double angle formula again to put it back to 2 sine theta. Sine 2 theta is gonna be 2 sine theta multiply cosine theta. So I think these expression I already gave you last week in the trig integrals. So yeah, always keep them when it comes to trig. There was a lot of expression that you're gonna use in in multiple sections. So keep them in your mind, because here when you have when you put it back in sine theta and cosine theta, this is how you're gonna solve. You're gonna use the right triangle. So here you have 1 over 10 inverse secant of x over 5, because secant theta is x over 5 here, minus 1 over 20 multiply 2 sine theta cosine theta. So, and then plus c. Then you have 1 over 10 secant inverse secant of x over 5 minus 2 with 1 over 2, no, 2 multiply 1 over 20 is 1 over 10. Sine theta, here, you look at the right triangle. Sine theta is square root of x squared minus 25. So square root of x squared minus 25 divided by x. Cosine is 5 over x plus c. So there's one extra step that you can do when you can simplify this. It's just like simplify 5 with 10 and then combine x here and x here to be x squared. But that's just algebra. I just want you guys to understand the step here that I make. Let's put it in green. This step that I make, where I use the double angle formula in here. And then in this step is where I use this part. And this step is where I use inverse sine in here. So I think using it in another color actually makes it better for us to understand where the hell I'm getting these things. And then this one is down here. Right? Are we clear over here before I get to 7.4? Okay, sure. So let's go to 7.4. So 7.4 is, I would say, in my opinion, it's the easiest way, but can be the hardest to some of you if you're not comfortable with algebra and like polynomials manipulation. So adding something, minus something, those kind of stuff. Then partial fraction, the idea behind partial fraction is really easy. You basically put it in this form. It was way harder than the ones I've been practicing, but you did a good job with explaining. Yeah, so like, yeah, I mean, I don't want to scare you, but like in the actual exam, at least in my exam that I have, because I didn't take the course with Dr. Katarzyna, I took it with another instructor, and her quizzes and everything is way harder than the final exam. But then it actually helps me a lot, by all means, because in the actual midterm or practice exam or the actual exam, I never actually spend the entire time doing it. It's just like, I think with the 2 hours I've given, I use like 40 minutes and I'm done with everything, and then I check all the stuff already. So I think it's a really good practice if you actually know more than like less, because if you it's more like you spend time every week, slightly more than other class, but then in the final exam it actually helps you because you kind of like get into the master level already. But anyway, it's my opinion, but if you just want to practice with the level of the class, that's completely fine. Then just try to do the exercise in the book instead of doing my practice problems, because they usually tend to be harder. But that is the level that you should expect, because as I said in the exam, especially with integration, there's not just simply like one technique, like you just apply it. There's no point, like that's not like understanding. So you should be able to use multiple techniques at the same time. That's the point. So when we talk about partial fractions, as I said, the idea is really easy. It's very simple. You just basically put it in the form of multiple fractions adding together, kind of like instead of one huge fractions that we're trying to solve, we break it down into smaller pieces and solve it individually. So here, when say if you have these are the types, but I guess you guys are already familiar with it based on the lectures. So I'm just saying here the general purpose is that when you put it into these fraction and you take integral, like each of them individually, it's way easier than like attempting the entire big fractions. So the step here is first make sure that the rational function is proper, and when we say proper, it means that the degree of the denominator, the maximum degree, say the highest degree in the numerator is x squared, is smaller than the highest degree in the denominator, say maybe x cubed or x fourth. If you choose it's proper, if not, use the long division. It's actually is the next example that I'll show you. But let's continue with this thing first. If the rational function is proper, then fully factor the denominator. This step is actually help us to choose what types that we're gonna put them like down here. So here we have, if we factor it and it's become fully factored and it gets to unrepeated linear factors, like it's gonna be just something over like something here is x minus a, x minus b, x minus c, and it doesn't have any power with these, then you're gonna use this type to break it down. If it have irreducible quadratic, this is the formula you're gonna put it. Remember, one key to remember here is that in the numerator, the highest degree in the numerator is always one less than the denominator. Here, the highest here is x, and the highest here is x squared. So it's one power of x different. If you have repeated linear factors, then say x minus a to the n, then you're going to do it n time. So a over x minus a plus b over x minus a squared plus c over x minus a cubed until you get to the nth power, and then just p over x minus b. So this is kind of like a thing to note. And if you, again, similar, if you do the unrepeated irreducible quadratic, here note the fact that even though you have x squared plus ax plus b to the n, the the numerator doesn't really change with that power. So say here you have ax plus b over x squared plus ax plus b. The next one is still cx plus d. It's not cx plus d square or anything. So you have, and also divided by that quadratic square. So whatever formula you keep here, it's gonna be like the general thing is the same. It's just that if you have the repeated, then you just have to do it multiple times. Nothing really changed in the numerator. And then after you break it down, you're gonna equating both sides. Use algebra to find what is a, b, and c. And we're gonna see that in, I think you already seen it in the lectures example anyway. But yeah, we're gonna do it again in example 4 and just integrate them. Now let's get started. Example 3 is where we use long division. So this is kind of like one thing I want to introduce you in case you were given something like this. This is a fraction, and if you note, the numerator has the highest power is the third power, x cubed, and here's just x. So it's not in the proper form yet, and I will put it in the proper form. So the way we do long division, some of you might have seen this in high school, but I guess it might be a long time since we actually attempted. So the way we use long division is that this is the, I'm going to write in this way. So the step is to use the highest power divided by the highest power on the right. So you have 2x cubed divided by 2x is going to be x squared. Note that you only do that for the highest power, like that division, 2x cubed divided by 2x. You don't do that for every terms here. What you're going to do here is that now you have x squared. You're going to multiply 2x to see, and then move it over here to see what we have left. So you have x squared multiplied 2x is 2x cubed, and you minus that. And you do the same thing with 1. X squared multiplied 1 is x squared. If you move it over here, you change the sign. So what we have here is 2x. You have this minus this. So you have 2x squared plus 7x plus 8. Now, this is one of the steps, and you're going to continue doing it until whatever numbers that you have here, the values is smaller than 2x. So say if you have a number here and it's smaller than 2x already, then you stop. But is there any questions with what I'm doing? It can be a little bit hard to understand with the long division if you guys haven't done it before. Again, if it's hard to understand, I would highly recommend look at Khan Academy video. That's actually where I actually learned this. So that's one of the other places. So if there's no problem with what I'm doing, I'm just gonna proceed with it. So you have 2x squared. It's still higher than 2x. So I'll do the division again. 2x squared divided by 2x is x. So again, you multiply back and move it over here to change the size. So you have negative 2x squared. X multiply 1 is x, and then you divide it. So what you have is 6x plus 8. Now it's 6x here and 2x. You can still divide. You have 3. And you have negative 6x, negative 3. So you have 5 left. Now 5 is smaller than 2x. So we stop the division there. So what we have here is that this integral is going to become x squared plus x plus 3 plus 5 divided by 2x plus 1 dx. So is it clear to you how we get these? Okay. Except for Api, would everyone is everyone good with this? The way we do long division? So basically this excuse me. This long division allow us to write the fact that 2x cubed plus 3x squared plus 7x plus 8. This is gonna equal 2x plus 1, x squared plus x plus 3. From this division we have, and then plus 5. So this is the quotient, and this is whatever I have left, the remaining. So after that, you can now everything divided by 2x plus 1. This is divided by 2x plus 1. So that is how we end up with this answer here. Is it clear of how we end up here? I mean, after you get here, basically everything is solved, so it's not a big deal anymore. So, okay, so we have that. So now it's just gonna solve it. It's x cubed over 3 plus x squared over 2 plus 3x plus 5 divided by 2 multiply. So here I just do it slow so that make it a little bit clearer to people. Since you have 2x plus 1, if you want to put it in the form of ln, then you need a 2 here because you need the derivative of 2x plus 1. So you're going to have x cubed over 3 plus x squared over 2 plus 3x plus 5 over 2 ln of 2x plus 1 plus c. So this is the key here. Don't forget the part that you have this thing. Because 2 here is basically 2 here is just derivative of 2x plus 1. So when you write in the form of like du over u, then this is the formula. You put it back into ln. So it should be clear to you guys now of the level that we're dealing with. So if we're all good here, let's go to example 4. So this one is where it actually applies integration partial fractions. So it'll be a little slow, but let's work on it. So see what time is it? Oh wow. Anyway, we're doing a good job. So if it's a good job, it doesn't take that much time. Okay. Here we have, let's check if it's a proper form. So the highest degree in the numerator here is x squared, and in the denominator is x cubed. So it's already in the proper form. Now the next step is that I'll fully factor the denominator. Have is x cubed minus x squared minus 2x. So let's fully factor it. I'll take x out of all of them because all of them will have x. So you have x squared minus x minus 2. And now we're going to continue factor it because this thing can be further factored. So you have x. I'll do some manipulation. Some of you will ask me like, how do you know that you're going to do that? I would say a lot of them come from practice and kind of like the way that I was taught calculus in high school. So my high school is like way harder than this. I already learned all of this in my high school. And it's not even like a college course. It's not like AP or anything. So it's just something that I have to deal with at my early life. So I get the intuition from the fact that I practice a lot. So if I would say again, if you do a lot of practice and like look at, like at first you might get it wrong, but if you look at the solutions and all of that, you're gonna see the fact that you can figure out what's going on. And doing a lot of that is just gonna give you kind of like some calculus intuition. So here, when you take this thing, so I can take x minus 2 out of each of them, plus x minus 2. And here, so you can take the x minus 2 out of all of them again. And inside we're going to have x plus 1. So I fully factor it into, and what we have is just unrepeated linear factors. If there's any questions of how we do this, let me know. I can ask Dr. Kesha to give you guys some practice on these factoring because it might be a problem. But I would say, I think in the exam it shouldn't be that bad. I don't think she's gonna make you guys factor a very crazy thing, but I would say this is like maybe like the highest level that she's gonna ask you to factor out. So if we all cool here, so I'm gonna proceed with partial fractions. You have 3x squared minus plus 7x minus 2 divided by x minus 2, x plus 1 dx. Now we're going to use the first form of the partial fractions because it's unrepeated linear factor. You're going to have a over x plus b over x minus 2 plus c over x plus 1 dx. Now I would ignore the dx and the integral sign and just working on the inner algebra. So we have 3x squared plus 7x minus 2 equal x minus 2, x plus 1 equal a over x plus b, x minus 2 plus c, x plus 1. So if we want to find what is a, b, and c, as I said, we have to put them in the same denominator. So same denominator is when you have x minus 2, x plus 1. Now to get from x to this big denominator, you have to multiply a by x minus 2 and x plus 1, right? It's kind of like make sure that, and then b, you have x minus 2 here in the denominator. You're going to put x and x plus 1 together. So you have b multiply x and x plus 1. And then you have c, x and x minus 2. So cx, x minus 2. Now we can ignore the denominator because they have the same denominator. We're just going to equate the two numerators together and find what's a, b, and c. This is again algebra. Plus 7x minus 2 is equal a. So I will distribute this two fraction together. You have x squared minus x minus 2 plus b, x squared plus x plus c, x squared minus 2x. If I'm going too slow as well, let me know so that I can speed it up because I think you guys already see the example in the lectures, so should be familiar with this now. So here we have x, and x squared, x, and then x to the 0, which is just a constant. So to find a, b, and c, we're going to have to put everything related to x squared together, everything related to x together, and everything a constant together. So if we do here, you're going to have a plus x squared multiply a plus b plus c. And then you have x is going to be negative a plus b minus 2c. And then the constant is just negative 2a because there's no constant for these two terms. So when I say equate them together and solve for a, b, c, this is what I mean. So when you put them, you have a plus b plus c. You just equate the coefficient in front of that term. So you have x squared and 3x squared. So you're going to equate 3 with a plus b plus c. Negative a plus b minus 2c is going to equal to 7. And then negative 2a is just equal to negative 2. So I wouldn't go through this step because it's just algebra. And what we have end up is a is going to be 1. Oh, damn. Just keep jumping. I don't understand this thing. Whenever it gets hard, that's what happens. For the other two, I don't have the notes here, so I'm just going to use a calculator to figure it out quickly. 1, 2, 3, 3, negative 1, 1, negative 2, 7, negative 2, 0, 0, negative 2. So we have a is 1, b is 4, and c is negative 2. So now we're going to have this initial integral is going to equal to the individual of them. So it's going to be 1 over x plus 4 over x minus 2 over x plus 1 dx. So things should be really easy now because it's just a bunch of ln together. But is there any questions with what I've been doing? I'll stop to explain it here so that make sure everyone is on the same page. So it's all silent, so I would say there's no questions. And so I'm just gonna solve this one quickly. So we have is gonna equal ln of x, absolute value of x actually, 4 ln of x minus 2 minus 2 ln of absolute value of x plus 1 plus c. Actually, in many exams, I would say they don't put it in this way because they're going to be way easy for you guys to figure out what's going on. But the way that they're going to use is they're going to group it using the properties of log. So here you have 4, right? Outside of ln of x minus 2. They're usually going to put the 4 into the power here. So instead of this 4 here, they're going to put it as 4 here. And then you put, instead of this 2, they're going to put the 2 here. And because this is a negative, you take this negative inside as well, it's going to be to the power of negative 2, which make it into the denominator. And what we end up having is that you're going to have ln of absolute value of x minus 2 to the 4th divided by x plus 1 square plus c. This is the way they're going to put it. So here you have the addition of many log together. Using the property of log, you can put it one into all one product. And here you have absolute value of x multiply x minus 2 to the 4th. And in the denominator, it's going to be x plus 1 square because it's a negative power. So before I jump to 7.5, any problems here? So if it's no problem, I'll go to 7.5. So 7.5 is where we put everything together and just like a general strategy to take integration. And so the step is at first simplifying the integrand, so whatever integral that you're given, look for some obvious thing or like some easy use sub to solve it. And then you use log inverse trick. It's gonna go in the order. So if you have the integral of any two types, so like logs, inverse trig, exponential, polynomial, like any combinations of them, then you're gonna use integration by parts. So that's a very systematic thing that you're gonna do. It's not very complicated when you have two different functions together. That's usually it's like a one click because you know the fact that it's gonna be integration by parts. Then if not, if you have trig integrals, then use the one that we have say last week, whether it's off power, even power in each of them, and then you try to like do some substitution. Then we have, or if it's in this form, a squared minus b squared x squared, or something with the square thing, then you use trig sub. Sometimes you might need to use u sub if it's get complicated, just like our first example. And maybe something else like the relations that I told you, like the very basic relations in trigonometry, like sine square plus cosine square is 1, or like secant square is equal to 1 plus tangent square, those kind of stuff. And then if we have irrational functions, the first thing that you have to come to mind usually is that partial fractions. But I would say always be careful here. Oh, shoot. Okay, it doesn't let me go back anymore. Okay. If there's any shorter way. Because a lot of times I saw my student immediately when they see rational fraction and it jumps ahead into partial fractions. And it actually makes their life a little bit miserable because there usually be some shorter way to resolve it. Partial fractions is usually only applicable if you have like a massive denominator. Then that's when you're going to use partial fractions. But for something kind of like simple, say like a quadratic function in the denominator and you can put it back into two linear, life can be a little bit easier that way. But that's about it. And always remember, choose the simplest way and fastest way. That's why I'm saying do not just go immediately into partial fractions, because partial fraction is usually really long and it's very algebra equally evolved. So you can easily make mistake when it comes to algebra. And there's not really a way that I can tell you like, okay, you can check it back in partial fractions. So it's always something to be careful with. And you might need to combine several techniques. I would say that's maybe the general case of the exam. So having said that, let's do some example. Let's see how many do I have here. Okay, so it's only 2 and it's not something that we learned before. Oh no, actually I shouldn't say it that way. It's not like all the techniques that we learned before. It can be either a combination of them or either the combination of them, or we're gonna have some techniques that we did use before, but it's like a long time ago and none of us actually think about it again. But because this integration exam is anything, it started from maybe like the end of Math 140 until now. So here we have this fractions, and I would say the first thing of course is partial fractions, but let's look at the denominator. So the denominator here you have x and then x squared and then you square it again, so the total power is x fifths. That's considered like a massive denominator to me, so I'm going to use partial fractions here. And look at the type, it's one linear factor and one repeated quadratic. With x squared plus 1, there's no way that you can put it smaller in two linear factors. So you're gonna have a over x plus bx plus c divided by x squared plus 1 plus dx plus e divided by x squared plus 1 square dx. And now again, I'm gonna ignore the integral sign and the dx side, and I'm just gonna focus on the algebra. So you have x squared plus 2x plus minus 1. minus 1 divided by x squared plus 1 square. So I'm going to put them in the denominator, same denominator. So x squared plus 1 square. So with the denominator it's x, you need to multiply x squared plus 1. X squared plus 1 square. Then you have bx plus c, multiply x squared plus 1. And then dx plus e is just multiply x. Now, we also ignore the denominator and just equate them together. So you have x squared plus 2x minus 1. Now, you have to expand this square and put everything with the same power together. So like everything related to x fourth together, everything x cubed together, everything x squared together. And that's before we can use the linear system of equation to solve them. So we have a x fourth plus 2x squared plus 1. Again, this is kind of like a reminder here. A plus b squared is going to equal a squared plus 2ab plus b squared. So it's going to have bx squared plus cx multiply x squared plus 1. I just multiply this x inside. This is an x, this is not a multiply side. And you have dx squared plus ex. We might have to do the addition a few more times. But here is you have x fourth and x fourth. You're going to put everything x fourth together. You have a plus b. Then you have x squared. So you only have x cubed. Cx multiply x squared. So you have plus cx cubed. There's no other x cubed here. Then you have x squared. So you have x squared is going to be 2a. A and then 2 here. And then b x squared with 1. And then you have d. And everything with x together, which is c plus e. And then everything without x at all. So it's going to be a. Now, put it in the system. A lot of you might be freaked out already. Like we have 5 unknowns and we have to solve like a 5 equation system. But don't freak out. Usually these, if it's given to you in the exam, it's not complicated at all, because the entire point is to be able to use integration and not to solve algebra. So it shouldn't be like super complicated, because that's not the main focus of this course. And you have a plus b. There's no x fourth over here, so a plus b is just going to equal 0. And then you have c also equals 0. Yeah, you already solved some of the unknowns. 2a plus b plus d. This is a d, this is not just equal to 1. C plus E equal to 2. So now we have 5 of them. So you have A equal to negative 1. A plus B equal to 0. So B is equal to 1. C equal to 0. With D and E, C is equal to 0. E is going to be 2 from this equation. And then 2A plus B. You have A, you have B here. 2A plus B is negative 2 plus 1 is negative 1. D minus 1 is 1. So D equal to 2. So D square. Oh, because let's come back to 7.4. So if you look at it here, when we have repeated irreducible quadratic, so you have it's gonna go until the nth power, right? So you have ax plus b divided by x squared plus ax plus b here, and the next fraction is going to be cx plus d over x squared plus ax plus b squared. So the denominator is kept there. The numerator is the same, in the same form, so it's still a linear fraction. It's a linear polynomial, but in the denominator it's going to be the square. So you have to do it several times as it go until the power you have here. So in our example, you have x squared plus 1 square, right? So you have to have first one fraction with ax plus b divided by x squared plus 1, and the second one is going to be cx plus d divided by x squared plus 1 square. So that's what we did here, right? So is it clear of how I get it? Sorry. Yeah. Okay, cool. So then we have, yeah, it's good that you guys asking this question. Again, it's help you better know it now than in the exam, right? You don't want to just figure out something really great when you're doing the exam. So, so our I now is going to equal, do we have U, C, and E? What do you mean? Do we have to use C and E? Well, I mean here you need, okay, first you have A, right? A over X. So the next thing, I would just say using all of the variable that I can think of in the alphabetical order. So you have B, X plus C. For the next one, it have to be dx plus e. As I say, it's in the same form, it's still a linear polynomial, but the coefficient is different. So you have to use dx plus e, and you cannot just use bx plus c again. You see what I'm saying? So the form is similar, so it's both linear, but the coefficient is different. So say here I can have, like, if you solve it, if you look at the result, you can clearly see the fact that bx plus c is x plus 0, but over here is 2x plus 2. So it's a completely different thing. It's different coefficient. So we cannot just say, okay, bx plus c here and then bx plus c over there. So yeah, so what we have here is we have negative 1 over x plus x over x squared plus 1 plus 2x plus 2 over x squared plus 1 squared dx. Now, I will go to the next slide to solve this because it's kind of complicated. So I equal negative 1 over x plus x divided by x squared plus 1 plus 2x plus 2 divided by x squared plus 1 squared dx. Now, the first one should be easy. It's just ln of x, so I wouldn't care about that. Now, the second one, can anyone tell me what do you think it is? It's actually very simple. Don't overthink it. How do you solve the second integral? It's very easy. Do not overthink it. Just type it in the chat room of whatever way that you think we're going to solve it. There are two options, the harder options and the easy options to solve that. Just tell me what you think, how you're going to solve it. Or for the integral in the middle, like integral of x over x squared plus 1. Exactly, you give me the two, both of the options. So u sub is the easier one. Tan inverse, no, not tan inverse, tan substitution. So substitute x as tangent of theta. That is the harder options. So in this case, that's what I try to tell you. Sometimes after you guys do trig sub, sometimes those things just have a haunt in your mind. Okay, I'm just going to use trig sub when I see those kind of square thing. But you forgot the fact that you have an easy option of using u sub. So here I'm going to use u sub for the second one. How about the third one? How about the third one? Yeah. Let me think. The third one, there, you can use. Actually, there are multiple ways to approach the third one. I would say that's not a very good idea. Yeah, I shouldn't do that. There's one thing you can do is that 2 over. No, partial fraction is actually another way, but it's the harder way. We can do the easy way, which is, let's show it here. So first thing is going to be negative ln or absolute value of x plus this is u sub. So I will put here, if you put, let me use another color, make it clearer for people. If you put u equal x squared plus 1, then you have du is going to be 2x dx. So your integral is now become du over 2 multiply 1 over u. So that's the second one. And now the third one. the easy options that I'm saying is that, again, you're going to use u sub, but the way you're going to do it is that you're going to break it down first. X squared plus 1 squared dx plus 2 over x squared plus 1 squared dx. Now, the first step, this part, is where you're going to use u sub. You have u equal x squared plus 1. Then you're going to have du is equal to 2x dx. That is u sub. And then this one is just, let me think about this. This one is where you have x equal tangent theta. This is where you use trig sub, but still better than doing partial fractions, honestly. Or they may be the same length, I don't know. But I would say this thing is pretty like simple in the way that they look already. So I would just stick with breaking them out, or you can use partial fractions again. But you're gonna end up having something like me, it here, and then you're just gonna, you know, again use trig sub to resolve it. So this u over here is also x squared plus 1. So what we have is negative ln of absolute value of x plus 1 over 2 ln of u, and u is x squared plus 1. And then you have again, this here is going to be plus du over u squared plus 2 here. So you have 2 tangent of x plus 1 square, which is going to give us dx is secant square d theta. So it's have secant square theta. Now, you can break it down into smaller, say like I1, I2, I3 before combining them together. I just do all of them at once because I don't have much space here. So you have half of ln of x squared plus 1 plus, now you have du over u squared, and the integral of that is just negative 1 over u, and now u is x squared plus 1. So that's what we have. And then over here, when you have 2 over tangent square plus 1 square. Now, this is tangent square plus 1. Tangent square plus 1 is just secant square. So you can simplify with the secant square here. But you have a square here, so what we have left is 2 over secant square d theta. And again, you can use the double angle formula to resolve it, because now this thing is just going to equal 2 cosine square d theta. So I wouldn't proceed further because it's pretty easy now, similar to our examples earlier. But again, I would say this exercise, this example, I think is the hardest that you might be given in the exam, because it's a lot of things going on. First, you use partial fractions, break it all down, and then you solve it in the way that you solve the individual one. See, you have here is u sub, then you have trig sub, and then you use double angle formula. There was a lot of things going on in this question, and I think this might be the hardest that you might be given. But that's about it. So before I go to the last example, let me know if there's any questions so far. Yeah, Natasha was right. We have u sub for this. But yeah, before I go to the last example, any questions? Even though you don't have any questions, just type it in so that I know and I can proceed. Cool. So now let's go to the last example. So the last example, let's get started. I would say try this one on your own. You guys are gonna be surprised that we don't use any technique that we learned at all in these questions. Not really no technique, but it doesn't have any that complicated like trig sub, trig integrals, or like things like partial fractions or anything. It's really simple in the way that if you break it down, the sine, so expand it, so you have sine square x minus 2 sine x cosine x plus cosine square x multiply sine 2x dx. Clearly, you have sine square and cosine square give you 1. Makes your life so much easier. 1. And then 2 sine x cosine x is another sine 2x, right? We just did earlier. So it's 2 sine x cosine x. And then you multiply sine 2x again. So it makes everything super easy now because all you do is just using double angle formula, manipulate them. You don't have any special techniques like integration by parts at all or those kind of stuff. So you have sine 2x minus sine square 2x dx. In many cases, like after my students do all the techniques and they look at this one, they're like, I have no idea what to use. Like, what techniques? Are you giving us something out of scope? And I was like, no, this is not something out of scope. It's like the basic thing that you should be able to know even before you take this course. So even this kind of question can be one of the things that you can expect. So I would say in this exam, study hard, do a lot of practice. And again, let me know if you have any questions. Make sure you understand everything before you do your exam. So here we're just going to resolve them very quickly. Negative 1 over 2 cosine 2x. And then we use the double angle formula here. 1 minus cosine 2x dx. 4x, I should say, because you double that. Double 2x is 4x. And this one is coming from the fact that you have cosine 2x of anything is 1 minus 2 sine square x, or 2 cosine square x minus 1, or cosine square x minus sine x, sine square x. So here, what we have is now just negative 1 over 2 cosine 2x, negative 1 over 2x, a negative sine square. Is that a negative sine square? Where is it? Here. Oh, are you talking about here? Yeah, it's not. It's sine, just sine square. Yeah, it's just sine square. Negative sine square. Yeah, right. It's negative sine square. Yeah, sorry for that. Should write it better. Yep. So we have integral of negative half. It's just negative half of x. Negative and negative is a plus. And you have 1. And then you have 1/4 cosine. Integral of cosine is just sine, and then you plus c. So you can simplify the thing based on making that for a sine 4x plus c. So this is our final answer for the questions. I hope there's no questions so far. If you have any questions, let me know right now with what we're doing. Because this is like kind of like it's a little bit out of expect for some of us if it doesn't use any technique at all. But it's a very basic integral. It might look difficult after we do all of these kind of techniques because we have no idea what techniques we're going to use. But this is, a very basic one. So I would say in all kind of examples, the first thing you got to think about, like before you actually jumped in and use some strategy for it, is that try to write something out of what's given in the statement. Sometimes it gives you some clue, like in this case, when you expand the square, that's where you see the magic going on, right? So kind of like put some line. I'm not asking you to write this entire 5 or 6 line, but as long as you do a few steps at the beginning, you can see one of the things going on. And in the following practice that you do, that's going to save you some time because you might be familiar yourself with that type, and it just make you see it immediately instead of needing to write down anymore. So since there's no more questions, I will so no more questions. These are the practice problems that I have. So I'll show it here. I haven't sent the slide to Dr. Kasher, I think. But you can always see this again based on the videos anyway. So this is a practice problem 1. practice problem 2, I'll put 26 of them. You're going to see that's my habit through every midterms. And then the last one. So there are a lot of practice and also in the book. So no need to worry about, okay, where do I find all of these problems to work on and try to test myself. Just make sure that you do all of these. And if you have any questions at all, please feel free to email me and I'll get you guys helped as soon as possible. If there's nothing else, I'll see you guys next week. And have a great weekend, guys. It's actually a Friday in Australia right now, so pretty funny. Yep, no problem. Have a great weekend.